Okay, so welcome back. Today we're going to be looking at using equivalence relations to make some new number systems. So we'll start with a number system that we know that we're comfortable with, the natural numbers. It's up to you whether you include 1, whether you include 0 in that system, or whether you just want to start at 1. For our purposes, either works just fine. Natural numbers are just all of the whole positive numbers. They're really great for counting. We understand them. But there's a problem, and the problem is we can't subtract. Okay, so the solution is we're going to make a new number system. Okay, so we're going to make a new number system which can accommodate negative numbers. The word for this is integers, but we can just call it whatever we want. Okay, and we're going to take two natural numbers to represent two parts of the integer. So we could think of it like, okay, take two natural numbers where the first number kind of represents the positive part of your integer and the second number represents the negative part. Okay, so we don't really have negative numbers in this system, but we're going to act as though we do. Okay, and we'll get some good results. Okay, so just to really clarify this, this part is a tuple. It's a two-dimensional natural number, and this part is just a single number integer part. Okay, let's look at the equivalence classes of these. So I've got this graph here. Let's say that this part represents A, the positive part, and this represents B, the negative part. So if we look at everywhere where the positive part is equal to the negative part, it's this set of numbers, this is the equivalence class of 0. Okay, all the positives and negatives balance out. If we look at this line here, everywhere here, the negatives are 1 more than the positives, which makes this the equivalence class to -1. And we can go ahead and find all the other equivalence classes. Okay, cool. So we see that our integers kind of correspond to diagonal lines in the two-dimensional natural number plane. But we don't just care about the numbers, we want to do operations with them. So one thing we can do with integers is we can add them up. So let's have a look at integer addition with this construction. Well, if I want to make a new addition system, I would just say, okay, let's say we have some number which has this form, and we're adding another number. Well, I'll go ahead and do this. We have okay, so we've got probably some system that we can use to add numbers, so now we can go ahead and define it. For addition, Okay, so with this equal sign, note I've got these two dots, and what that represents is I'm defining a new operation and I'm giving the definition here. Okay, right, cool. So we know how to add things up, but we also need to check that this addition system is consistent. And to do that, we also need a notion of equality. Okay, so what would it mean if I had two numbers which were equal to each other? Okay, so we've got that with their integer representations, but we can't have, subtraction when we're looking at natural numbers. So instead I'm just going to shift everything around and make those negatives into positives. So we have okay, and this is a fine kind of rule that we can use, so we can define equality. Okay, so if I pick two integers and I look at their representations, if this equation is true, then we can say, yeah, these two are equal to each other. Okay, so where we're at so far, we have a notion of integers being equal by some equivalence relation, and we have a definition for the operation of adding. We now need to check that our operation is well defined. In other words, if I have a different representation which is equivalent to the same number, then when I add those different representations together, do I get the same result? So let's check this. I'll call this condition 1, 2. I'll leave that one, that's fine. So by condition 1, we have this. And by condition 2, we have that. And now we can go ahead and look at what formula we have here and just kind of shuffle things around a little bit. So where are we at? We have that this number relates to its representations. We have that relationship there. This number relates to its representations. We have that relationship there. Then we need to test that when we add these representations together, we still relate to what we should be getting the same number. So this is the condition that we want to test. Okay. So yep, just double checking. So when we add together, we have a plus c. Okay, great, awesome. Okay, so let's write this out. We have so remember, by the equivalence relation, we want this sum to be equal to this sum. So I'll start with just that first sum, write that out. Then I'm going to rearrange things as we can use them here. So we have, write this out, we have a hat plus b, and then we have c hat plus d. And then applying 1 and 2, a hat plus b is the same as b hat plus a. And c hat plus d is the same as d hat plus c. Let me double check. And that is equal to b plus d, b hat plus d hat plus, and then a and c. And so, yes, that's correct. Then, yeah, plus operation is well defined. As an exercise, okay, so now we have addition and we have negative numbers, so we should have an additive inverse. So I need to, this is an exercise to try. Okay, we need to just double check that our additive inverse of an element is given by just reversing its components. Okay, cool. So, hope you had fun, and in the next video we'll try some other things.